Welcome back. Let us go through the question. In deriving Bernoulli's equation, we equated the work done on the fluid in the tube to its change in the potential and kinetic energy. So what is the largest average velocity of blood flow in an artery of diameter 2 into 10 to the power minus 3 meter if the flow must remain laminar? So the diameter of the artery is 2 into 10 to the power minus 3 meter. The viscosity of blood is eta, which is equal to 2.08 into 10 to the power minus 3 Pascal second. The density of blood is, which is represented by rho, is 1.06 into 10 to the power 3 kg per meter cube. The average velocity is given by V average equals N R eta divided by rho d. So taking the maximum value of Reynolds number, which is 2000, at which laminar flow takes place, we have V average max to be equal to 1.97 meter per second. The next question is, do the dissipative forces become more important as the fluid velocity increases? Discuss qualitatively. As the fluid velocity increases, the dissipative forces become important as turbulence rises, due to which drag due to friction forces increases.